What do you understand by language of chemistry?
So in that chapter in 8th standard, we had learned about different valencies and how to do crisscross method.
Okay. So, see, today class would be a bit of a recap of that because that's really important. So, chemistry has its own language to describe elements, compounds, and reactions. This language includes the understanding of chemical symbols, where we have H for hydrogen, O for oxygen, valency, the combining capacity of each element. So we need to understand what is valency of different elements, and even radicals and ions. Okay. Then we learn how to form chemical formulas, which you learned last year by crisscross method. So we are going to recap a lot of this. Then the understanding of chemical equations and balancing chemical equation. That's also what I think you know a bit of balancing chemical equation from last year. So we need to do a little bit of continuation of that. What are chemical symbols? Chemical symbols are shorthand notations for elements. These symbols are either derived from the English name or from the Latin name. For example, for hydrogen, the symbol is H, oxygen, it's O, sodium, it's Na, and for gold, it is Au. Sodium symbol Na comes from its Latin name, which is natrium. Same goes for gold. The symbol comes from its Latin name, that is aurum. Okay. So let's quickly see, check your knowledge on symbols. Manganese,
Mg.
Mg. Is that correct? Is Mg correct for manganese?
No,
Manganese
sir.
is not Mg. Mg is
Only M. Only
magnesium.
M.
No, even M is not correct. Please try to participate, whatever you know. Don't feel shy.
Mn, sir?
Mn is for manganese. Good. For carbon,
C.
just a C.
C.
Okay. What is symbol for bromine?
Br.
Br.
B. Very good. Okay. What is symbol for nitrogen?
N.
N.
Just a N. Next symbol, next element is lead. What is symbol for lead?
Pb.
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 Vanshika, can you tell me the next one? Barium,
So BA.
Ba. Okay. Lashya. Okay. Lashya, what is symbol for sodium?
Na.
Okay.
Na. Na.
Na. Okay, very good. Silver, Mona, what is symbol for silver?
Sir, Ag.
Ag. Okay, Tananya. Okay, nickel, Tananya. Mana wants to answer. Mana, what is nickel?
Ni.
Ni. Okay, very good. Next is boron. So Yashasvi, what is symbol for boron?
B.
Mona, what is iodine?
Sir, I.
Okay. Mana, what is cobalt?
CO.
Yashasvi, what's sulfur?
S.
Phosphorus? Vanshika. Am I missing out anyone? Okay.
So P.
Okay, Vanshika. Gold again.
So AU.
AU. Very good. Who would like to tell for 10?
So
Sir,
SN.
N.
SN for 10. Okay. Oxygen?
O, sir.
Oh, okay. Let's finish this fast now. I think you are familiar. Most of you are familiar. Calcium.
CA.
Ca. Yeah. Okay. Fluorine. What's symbol for fluorine? Fl? No.
Fu.
No.
Only F.
It's
Yeah,
only
only
F. It's only F. Okay. Now, what
Cr.
about chromium?
CR.
Cr.
Cr. Phosphorus?
PH.
No.
P, sir.
P. P.
The first 20 element you need to be very thorough. Okay. So phosphorus is just a P. Mercury.
Hg.
HG.
H. Hg is for mercury. Very good. Iron.
FE.
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 Yes. Potassium.
K.
K, sir.
Okay, final, tungsten.
W.
Good. Who said?
Yashasvi.
Yes, Shri said that. Okay, very good. So all of you are familiar with symbols, the elements which we discussed here. Almost everything is important. Moving to the next part. What is valency?
So the number of elements an atom can donate or accept.
The number of electron, right?
Yeah, the
Yes,
number
sir.
of
Yes.
electrons.
So valency defines the number of electron an atom can donate, accept, or share. Okay, so Mona, can you also put a little light upon why do they do that?
If like the last shell is not complete, they tend to like give away or accept to make it complete.
Okay, so that is a natural tendency of an element to stabilize the electronic configuration. So if the last cell is not complete, something like 282, so they can either lose the two electron, or if it's like this 2, 8, and 7,
We can gain one.
they can gain one and try to become stable.
So an
Good.
anion.
Oh, and form an anion. Very good. Okay. So valency is defined as the combining capacity of an atom or radical. In other words, it's the number of electron which the atom loses, gains, or shares. Okay, there's another angle to it also. How many of you have heard about sharing of electron between atoms? Mona says yes. Anyone heard about sharing of electron or atom? Only Manav says yes. Anyone else have heard about sharing of electron between atoms, or do they just give or take? Vanshika, what's your opinion on this?
Sir, I'm not sure. I've only heard about give and take.
Give and take, you're sure?
Yes, sir.
Okay,
No,
so
they can
this
never do it.
So covalent bond and electrovalent bond.
Yeah.
covalent and electrovalent. Okay, nice. Lasha. Okay, Lasha, you heard about give and take?
Yes, sir, I have.
And have you heard about sharing of electrons?
Yes, sir.
Okay, okay. So coming back to our topic here, I was saying that valency means it's the combining capacity, means it is the number of atom electron an atom loses or it gains or it also sometimes shares. Okay, so and this the atom does to attain a stable electronic configuration. For example, here hydrogen valency is 1 because electronic configuration of hydrogen is 1. It's just one electron in the outermost shell. So therefore, hydrogen can either lose that electron or gain that electron. Which one hydrogen does? Does it give electron or lose electron? Oh, sorry, lose electron or take electron? Anyone has an opinion on that? Like, what does hydrogen do normally? It gives electron or takes electron? Okay, if
Sir,
hydrogen
it,
takes electron, it becomes H minus. Yeah, Vanshika, you're trying to say something?
sir does both, right?
It does
It
both.
gives.
It gives electron also. So hydrogen can take an electron and also give an electron. And sharing, since a lot of you are not familiar, we'll talk about that later. It can also share electron. Gains, sorry, it gives an electron, it becomes positive ion, and if it accepts an electron, it becomes negative ion. These are anions. The negative ones are known as anions, while the positive ones are known as cations.
Cation.
As a cation, we call hydrogen itself. Like for the cation hydrogen, we don't have a different name. It is known as hydrogen itself. But when it takes electron and shows a negative valency, that time the same hydrogen becomes an anion, and the name for that anion is, what is the name for this anion? H minus anion. This is called as hydride. Okay. So when hydrogen takes an electron and becomes negative anion, it is known as hydride. Clear? Oxygen has valency of 2. Okay, who will tell me electronic configuration for oxygen?
2 7.
No,
2 6.
it is 2 6. Atomic number is 8. So electronic configuration is 2 comma 6. Okay, therefore it is deficient by 2 electron so that it can have a stable electronic configuration, right? So if we give 2 to oxygen, it will have 8 in the outermost shell, and 8 for an atom is considered to be stable. Correct. That is called as octet rule. What is the electronic configuration for carbon?
So 2 and 4.
2, 4.
2 and 4. So it has 4 in the outermost cell. So this carbon can lose 4 and become stable. It can gain 4 and become stable.
Yes, sir.
But
It
trust me,
neither.
this carbon does neither of this. Okay, that I'll teach you later on, but carbon does neither of this. It actually shares 4. I'm just deviating a little from the topic to see if you know the electronic configuration of first 20 elements properly. So, electronic configuration. Okay, do that, I think I need a little help in listing the elements. So, let's go. Vanshika, the first 5 elements.
So hydrogen, helium, lithium, beryllium, boron, and carbon.
Okay. The next 5, Mona.
Yes, sir. Nitrogen, oxygen, fluorine, neon, and sodium.
I think we have missed something because sodium is 11 and we just said 5 plus 5. So, what did we miss here? Someone missed.
So
So
beryllium.
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 So, you said
Beryllium.
beryllium, I missed it.
Yes, sir.
Okay, no problem. So, let's just complete the table. So, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, the next set of element from 11 to 15. Let's Manav try. Let Manav try this one.
Okay. Sodium, magnesium, aluminum, silicon, and phosphorus.
And phosphorus. Okay. Tananya, can you tell me the last 5?
Yes, sir. Sulfur, chlorine, argon, potassium, calcium.
Okay. Okay.
Yes, sir.
Yeah, yeah. Now I'll remember. So, Lashia, next 5, you know?
Sir, next time I don't know.
Okay. Yes, yes, you know the next 5?
So I'm not sure of the next one.
Anyone knows the next 5? So, it's not in our syllabus. Scandium, vanadium, titanium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So you need to help me write the electronic configuration. I think the first few are easy. Hydrogen, what's the electronic configuration for hydrogen?
1,
1.
1. Helium?
2,
Two.
Okay. Then lithium?
2, 1.
Okay, so this is easy. So let me fill this. Beryllium is 2, 2. Tell me if I am going wrong anywhere. Boron is 2, 3. Carbon is 2, 4. Nitrogen is 2, 5. Oxygen is 2, 6. Fluorine is 2, 7. Neon is 2, 8. Okay, sodium is 2, 9. Let me know if I go wrong somewhere.
Yes, sir.
2, 8, and 1. 2, 8, 1. Not 2.
281.
Oh, why are you doing like that?
So because
The max cell.
Oh, we have already reached the maximum capacity for
Electrons
the.
are max cell.
Okay, so okay, I get that. I get that. I understood. I'll remember that and I'll not repeat it again. So moving further, magnesium is 282, 283. Silicon is 284. Phosphorus is 285. Sulfur is 286. Chlorine is 2, 8, and 7. Argon is 2, 8, and 8. Okay, potassium is 2, 8, and 9.
1.
Not 9.
2, 8, 8, 1. 2, 8,
881.
8,
1.
But why are you doing like that? Can we not fill one more in the third cell?
Sir, can you repeat?
See, I was writing for potassium as 281. Sorry, 289. But some of your friend here, Lash, corrected me and told me that, sir, it's 2881 and not 289. I just want to understand why.
Sir, because each cell can only contain 8 electrons in it.
Is that true? I think different cell have different capacity. Maximum capacity for first cell is 2, so that's why we are not filling after 2. Maximum capacity for second cell is 8, and that's why we are not filling after 8. Correct? But what is maximum capacity for the third cell? Vanshika, what's maximum capacity for the third cell?
So 8.
8?
So
Uh,
it can be 18.
it is 18.
Yes.
Okay. Mona, what is maximum capacity for the third cell?
So I think it's 18 as well.
18. Okay. Yashasvi and Lasha, what's your opinion on this?
Same, sir.
Same, sir. 18.
18. Are you sure? Not 8. Okay.
No, sir.
Tananya and Mana, what are your opinion on this?
It's the same.
18.
Same 18. Okay. Then my simple question is, why are you not filling potassium last electron in the third cell? Any one of you had the same doubt before?
Me.
Okay. So, are you interested in the answer? Okay. How many of you are interested in knowing why we are not filling the third cell, though there is more capacity there? Or
Yes.
anyone knows the answer? Anyone knows the answer? Okay. Next element is calcium. So calcium is 288 and 2. Okay. See, the reason why you don't know the answer for this question, like why you're not filling the remaining places of the third cell, is because the syllabus actually ends at calcium and we don't pay much attention to it. Moving further, in scandium, if I just need to know, like suppose if I want to know what is electronic configuration for scandium, scandium electronic configuration is 2 8 and then 9 and then 2. You see what's happening now? Vanadium is 2 8 10 and 2. Titanium is 2 8, sorry, not titanium, yeah, so is 2 8 11 and 2. Clear? And this way we continue to fill the third cell, and the last one here is 2 8 18 and 2. Am I clear?
Yes, sir.
So it's not that we are not going to fill the third cell, but we are going to fill that a little later. So that's how it is. So third cell has 18 electrons. We fill that from atomic number 21 to atomic number 30, the remaining 10 places. Okay, so you must have got some idea to your doubts. And same goes for the other elements in higher periodic table as well. It's not that we fill the entire third cell or the entire fourth cell and then we move to the next cell. In bigger cells, okay, after cell 3 onwards, we fill a part of it, we go to the fourth cell, we fill a few there, we come back and fill the remaining. Is that clear?
Yes, sir.
And what is that exact order in which we fill the different periods? About that we have to study in higher classes. So we will leave that part. This was just for your understanding that if you have any doubts why I'm not filling 18, it is only because as per the rule they are supposed to be filled later on after filling 2 in the fourth cell. Clear? That's it. Now that you know the electronic configuration of these elements, you can also actually understand their valency. So what is valency for lithium? Lithium
We.
is no, lithium valency is not 3. Lithium has electronic configuration of 2 comma 1. So it has one electron in the valence cell. So see, what is valency for lithium? Any idea? It's written right on the screen for you. You can say yes sir or no sir.
So 1.
1. Can you explain how? How is valency 1? Okay, I think you need a little explanation. So let me explain this one, then you can explain the next one. Lithium has 2 comma 1 electronic configuration. That means it has one electron in the second cell. Hence, the electronic configuration is not stable. Having one or two or three electron in the outermost cell, like until you have 8 electron from second cell onwards, it's not stable. Like stability means having 8 in the second cell onwards. And for this first cell only, there is an exception. Stability means 2. Okay. For second, third, fourth cell, stability means 8 electrons. This means this lithium is not stable because it has one extra electron in the second cell. Right. So in order to achieve a stable configuration, it needs to lose this one electron. So there will be a loss of one electron. Hence the valency is plus one. Plus one means losing one electron. I hope that's clear.
Yes.
So Yashasvi, can you tell me what's the valency for beryllium?
So 2.
Beryllium is plus 2. And for boron?
+3.
Right. Tananya, for carbon?
+4.
A plus
And
4.
-4.
And minus 4. Because it can give or take both. That's right, Manav. That's your. That's how you see it, right? It has 4, so it can give 4 or take 4, right?
Yes, yes.
So plus or minus. Okay. I'm just leaving it right as 4 for now. Okay. What about nitrogen? Vanshika, what is valency for nitrogen?
So 3.
Plus 3 or minus 3?
So -3.
Okay. So minus 3 because it needs 3 to have a stable electronic configuration. What about oxygen?
-2.
Fluorine?
-1.
Minus 1. Sodium? The same pattern repeats, right? So it is plus.
1.
Magnesium?
+2.
Aluminium?
+3.
Silica?
±4.
Plus or minus 4. Okay. Phosphorus?
Well, -3 or +5 for this one.
Okay. Sometimes it's plus 5 also because phosphorus is also seeing losing 5 electron. The reason for that we'll see later. Okay. Sulfur has 6. Sulfur doesn't lose 6. So it is only minus 2. And chlorine is minus 1. Argon has no valency because it's a noble gas. Valency of noble gas is 0. It neither gives or takes electron. Right? So neon here is a noble gas. Helium is a noble gas. They have stable electronic configuration. Even argon here is a noble gas. They have stable electronic configuration. It means they have either 2 for helium or 8 for the rest in their outermost cell. So they don't give or take electron. They're stable. They're happy. Potassium has 1 electron in the outermost cell. So valency is plus 1. And for calcium, valency is plus 2. So all of you understood how we can find valency from the electronic configuration for various elements? Right? Like for example, if I ask you, what is atomic number 15? Let's see. Rapid fire. Atomic number 15. Anyone can say.
Phosphorus.
Okay. The element before argon.
Chlorine.
Atomic number of the element after potassium.
20.
So
Sim-
20.
20.
okay. A noble gas with electronic configuration 2. A noble gas with an electronic configuration of just a 2.
Helium.
It's helium.
Helium.
Valency for nitrogen.
-3.
Number of cells in potassium. How many cells it has? Potassium. 4 cells. 2, 8, 8 and 1. The fourth cell has 1. Clear? Okay. Is it compulsory that every element has a fixed valency? You will find that sometimes in our periodic table, you come across elements which have variable valency, which don't have one valency, which has multiple valencies. Can you give me example of such elements?
Copper.
Carbon.
Okay, copper. Who said copper?
So me, Mauna.
Mona. Mona, copper. What are the valencies of copper?
So 1 and 2.
+1 and +2.
+2.
Then next, iron. Iron is
+2 and 3.
+2 and +3. Okay, good. Any other element with variable valency?
Silver 1 and 2. +1 and
Silver. Very good. So silver is +1 and
+2.
+2. Okay. So certain elements have variable valency. See, whenever they have variable valency, you will also find one more pattern. The one which has a lower valency is always us. Okay. So this is like cuprous. Okay. But the one with a higher valency is known as cup-
Cupric.
cupric. This is again ferrous and ferric. And this is argentus. And this is argentic. Okay. Next, ions or radicals. An ion or radical is an atom or a group of atom of same or different element, okay, with positive or negative charge. Okay. So an ion or a radical is an atom. It can be a single atom or it can be a group of atom which together have a single charge, right? A single unit of charge. Radicals have their own combining power based on which they form chemical formula. So, an example of such radical is sulfate. So, sulfate formula, you're familiar, it is SO4. So, it is not made up of one single atom, but it is made up of group of atom. And together they have a combining capacity, means together they are taking two electrons, right? Similarly, another radical is nitrate, NO3, 1 minus. So formula for this radical is NO3, 1 nitrogen, 3 oxygen, and together it has a valency of -1. So radicals have their own combining power. This is their combining power, -2 or -1, based on which they form a chemical formula. Okay. So here this whole group, like 1 sulfur and 4 oxygen, or 1 nitrogen and 3 oxygen, they are together behaving as a single unit and they have a overall sum charge. Is that clear?
Yes, sir.
Okay, this is something you had such tables last year also, which we need to revise even now. We will have a look at that in the next page. So, number of charge indicates the number of electrons lost or gained by an atom or a group of atom. Depending on the number of charge, the ions or radicals are described as monovalent, divalent, trivalent, and tetravalent. Means if it has a +1 charge, it can be called as a monovalent ion. If it has +2 charge, it's a divalent. If it has +3 charge, it's a trivalent. And same even goes for the minus charges. Like it can be divalent, electropositive, or electronegative. Okay, let's see that on the next page. So here I just written the name of the positive ions and we will together try to figure out the formula. Okay, so let's try it out. So ammonium, let's start with,
NH
okay, Manav is telling. Fine, Manav.
uh, 4.
NH4 and the charge is +1. Ammonium is NH4 +1. It's already written here, monovalent. Means they all have valency 1. So, okay, Yashasvi, can you help me with formula for cuprous?
So CU. So I'm not sure.
See, cuprous is Cu and valency is +1. Actually, all of them which I have written here is +1. Okay, so cuprous is Cu +1. Okay,
Yes.
okay. Next is argentus. Yes, mono. What is Argentus? Formula and valency.
No, sir, I could not hear you, but now I can. But I'm not
Okay.
sure, sir.
Argentus is just a Latin name for silver.
Yes, sir.
Silver
So
is a, so
is
it
it
is.
AR
No, it's not
plus two?
AR. AG. Silver is AG.
Sorry.
Okay. Here, I'm sorry. It's plus one. All of this is plus one. So ammonium is NH4 plus one. Cuprous is plus one. Mercurius is again plus one, and Argentus is again plus one. Okay. Vanshika, what is argentic?
So Ag plus 2.
Ag plus two. This section is all plus two. Okay. So ferrous, Vanshika, can you tell for ferrous?
Sir, is it Fe plus 2?
Fe plus two. Okay. So let's just go ahead with this. What is formula for stannous? Stannous is another name for tin. Okay. So this is Sn plus two. Okay. This needs to be learned. Okay. There is no shortcut to this. Cupric is Cu2 plus, magnesium is Mg2 plus, and calcium is Ca2 plus. Okay, aluminium is Al3 plus. Let's quickly finish. Whoever knows can just tell. So chromium is
Cr3 plus.
Cr3 plus. Ferric is
Fe3 plus.
Fe3 plus. Plumbic is Pb4 plus. And stannic is Sn2 plus. Sorry, Sn4 plus. Okay, this is the negative ions or the radicals we have. So please make sure that the last year radical table which you have, those obviously who are joining for next time, tomorrow there is a session for physics. So the two trial session which I have mentioned in that list is one for physics and one for chemistry. So today was chemistry, tomorrow is physics. So hope to see you over there. Uh, just as I shared with you. Okay. In order to get more familiar to me and my teaching methods, I'm sharing you one of my videos from your ninth grade playlist. Last year batch. There are a lot of interactions with. You'll find others on the same link, so you can have a look at it so that you really understand how this whole thing works, the interaction and all works in the classroom. Okay. Rest, if you have any doubts, you can reach me out. For today's class, we'll leave it here because I think slowly the energy is going a little. But in a longer run, if you are seriously considering this online classes, I would request you, okay, and in a more positive way, it will be a discipline for the class that we attend with the camera on. How many of you are comfortable with that? How do you attend your other classes, Vanshika? With the camera on or off?
Sir, with the camera on.
Camera on, yeah. So again, the same for other students over here also. So if you choose to attend these classes, no, you can. I will request you to keep your camera on because it makes the interaction more healthy. Okay, and if suppose at any point the student is losing interest, if I can see you, I can drag you better into the conversation. So it increases the productivity and the efficiency of the whole setup. Okay, so for today, we just leave it till here. Obviously, there will be more even demo classes on chemistry where we'll try to continue further. As of now, two classes were scheduled, one for chemistry and one for physics. So trial classes are mainly to check your interaction and your basic understanding of the subject. So hope to see you again like tomorrow if you join at the same time. Okay, thank you and bye everyone for now.
Thank you, sir.
Thank you, sir.
Thank you.